In the last chapter, all the rules for buoyancy were stated in terms of fluids rather than liquids. The reason is because the rules hold for gases as well as liquids. The physical laws that explain how a blimp stays aloft in the air are the same that explain a fish being aloft in water. Archimedes' principle for air states that an object surrounded by air is buoyed up by a force equal to the weight of the air displaced. A cubic meter of air at ordinary atmospheric pressure and room temperature has a mass of about 1.2 kilograms. Its weight is about 12 newtons. Any 1 cubic meter object in air is buoyed up with a force of 12 newtons. If the mass of the object is greater than 1.2 kilograms, it will fall to the ground when released. If the object has a mass less than 1.2 kilograms, it will rise in the air. A gas-filled balloon rises in the air because it's less dense than the surrounding air. Everything is buoyed up with a force equal to the weight of the air it displaces. So what happens to a rubber helium-filled balloon when you let it go? Because gas is compressible and air pressure decreases with height, as the balloon rises it will expand. This causes the balloon's density to decrease. You'd think that the buoyant force would increase, but as the balloon rises, the atmosphere's density decreases too. Eventually, the balloon and atmosphere reach the same density and the balloon floats at a constant altitude until the helium leaks out and it descends back to Earth. In a gas-filled balloon or airship, the weight of the gas is significant. The helium that fills the Goodyear blimp weighs 2,260 pounds. That's over a ton. An air bubble in water also expands as it rises. Like a balloon, the air bubble will expand as it rises, and its density decreases. Unlike the balloon in air, the density of water is constant. The buoyant force increases as the bubble rises and its acceleration increases.